Welcome to the session. Before we begin with anything, there is a QR code on the screen, and there is a link, ak.ms/CoCo101. You go to this. There are some preparation steps, and that will help you get access to an environment that you will need to follow with us for the hands-on portions of this session. OK. I hope everyone has done this. From time to time, I'll pop up the screen so that you can go to the link and check it out. OK, so in this session, we are going to talk about confidential containers. And you'll learn how to secure containerized workloads using confidential containers over a shared infrastructure. The agenda, the way we are going to go over this workshop is that we're going to talk about confidential compute first, which is the backing technology for confidential containers. Then we'll learn about the project itself, what it is, how it uses confidential compute. We'll look at some diagrams, which will help you understand how the two fit together. And finally, we have the hands-on demos, where you'll learn how you can deploy your real-world scenarios and some applications around confidential containers. Yes. So let's get started. Something about me. I am Archana. I work with Azure Linux team at Microsoft. I work to support confidential containers, container pods on Azure Kubernetes services. Suraj?
Thank you. So I'm Suraj. I also work for Microsoft on the Azure Kubernetes service. And I have been a contributor of confidential containers project, the CNCF project. And yeah, that's me.
Cool. OK, again, please go to that link. Follow the preparation steps. You will get access to an Azure environment. And you'll need that to follow along with the hands-on portions of this session. If you have not done something previously, it's fine. It's pretty straightforward, very easy. But please encourage you to check it out.
Also, while Archana is giving the presentation, if you have any problems with the setup, please raise hands or just holler at us, and then I'll come there and help you with the setup. OK.
OK. So let's talk about confidential compute. How many of you have heard the term before? That's a good number, yes. OK. Let's try to understand what it is. OK, you see a diagram on the screen. This diagram represents a compute unit. This could be your virtual machine on shared cloud infrastructure, or this could be just your laptop or on-prem server, anything. And you can see there are some components on this unit. You can see that there is a cable coming in, and then there is a disk. There is your RAM and CPU. So what these components essentially represent here are the forms of data. Through your disk, in your disk, you have the data which lies at rest. This could be your application data, the databases. And the thing is that we have mechanisms to protect that data which lies at rest. For example, using BitLocker. So even if somebody steals your hard drive, they take it with them, they try to unlock it, they'll not be able to get into it. So that's the point. So it's protected. The data at rest, as of today, is protected. The next is your data which is coming into your systems over the wire. The data in transit, we have mechanisms to protect it traditionally using HTTPS or TLS, SSL. We have that. The third form of data, which is the one that lies in your processor, which is being operated upon, that is, as of today, unencrypted or unprotected. So the bottom line is that if somebody had access to your RAM and they got a hold of the process data, they could look into it, they could snoop into it, and they could just do anything with it. That is what confidential compute, that's where it comes in and changes the scenario. Confidential compute ensures that the data which is in use in processor remains protected, and thereby completing data protection in all of its forms. So throughout its life cycle, data is now protected. Think of it as a three-legged tool of data protection, and without confidential compute, it is kind of wobbly. So yeah, that's it. Confidential compute is hardware-backed technology. What that means is that the memory encryption or the data protection happens on the hardware level. And it's backed by chip vendors such as AMD, TDX, which enables virtual machines as the trusted execution environments, and we have ARM trust zones, which are used, for example, in your payment applications. And NVIDIA has launched confidential GPUs for confidential inferencing. So what that means is, even while your AI workloads, they're inferencing in GPU, so even that is protected. Let's try to understand how that happens. So think of what confidential compute does is it creates a secure enclave. Think of it as a partition in your CPU, and the applications would run inside it as it normally runs. But the difference is that it is shielded from the outside world. So it's not just isolation, but it is like a lock from inside. Even if somebody had physical access to that area, and they look into it, they'll see gibberish. They'll not understand anything because it's encrypted at the hardware level itself. So it's a zone, it's an enclave which is shielded. And this could be on application level, and this could be on VM-based level. So Intel SGX, for example, provides secure enclaves on application level. And then TDX, NCF, SNP enable it on VM level. So for this talk, we're going to focus on VM. Because VMs allow easy lift and shift, and with application enclaves, you need to change the way you're operating with it, so you need additional things, and VMs make it very easy to just move your applications. Moving on. So trusted compute base is basically the components of the system that you need to trust in order to deploy your workloads. And traditionally, it includes hardware. That could be your processor, TPM chips, BIOS, firmware, and then the host kernel and the host OS, hypervisor, if you're on cloud infra, hypervisor, then the guest. What confidential compute does is take a lot of components out of this from the trusted base. So essentially, we have only the processor, which is given by chip vendors, the CoCo confidential compute hardware, and then firmware is removed, kernel, host OS, hypervisor. They are all removed from that trust boundary. And we have only the processor and the guest OS to trust. And you can verify the authenticity of this trusted execution environment using a process called attestation that basically generates a report of the system, and you can verify it with public keys, which are vendored by the chip makers. So the point is that when you have a bigger TCB, when you have a bigger trusted compute base, the chances of your system getting compromised is higher, and CoCo reduces that TCB. Okay. Again, on the screen, we have a QR code, and we have a link, ak.ms, CoCo 101. You can go to this link and check out the preparation steps for the hands-on portions of this demo.
Anybody having issues so far with the setup? Okay, I'll come to you folks here.
Okay, so let's try to understand why do we need confidential compute? The why. So we have data privacy and regulatory laws, And DORA is one of those which has come up now in European Union. And the role of confidential computing is, the role that confidential computing plays there is to protect the data in all of its life cycle. So DORA, for example, requires that your data is protected at rest, in transit, and in use. And confidential computing as a technology comes there and helps you achieve that. Next is, with the rise of AI and LLM models, you don't just look at protecting the model weights. You also need to think about protecting the inputs and the analysis part of it. So that's where GPUs have come, and that's where, for example, Azure OpenAI has now announced a preview of confidential inferencing. So you can go and check that out. And anywhere where you're dealing with sensitive data, you can use confidential computing, such as healthcare, finance, or government organizations. Anywhere where you're dealing with sensitive workloads, confidential compute comes into the picture and helps you achieve the protection at all levels. Protection against insider threats. Let's try to understand what that is. So think of your workload running on a shared infrastructure. So when you're running your workload on something like a VM, which is on cloud, you're trusting the hypervisor, you're trusting the host kernel, you're trusting a lot of components which have access to the processor itself. Now what that entails is that, let's say somebody, and this could be any component that can have access to your RAM. And let's say there's a malicious actor, and this actor has wrong intentions, and they get a hold of a process which is running inside your CPU, and they do a memory dump of that. You can actually do this right now, like take a process from your system and run these commands, and you'll see that you're able to see the data that is associated with that process as it is. And with confidential compute in picture, you'll see gibberish if you run these commands again. So that's. Now, what's confidential containers? It's a CNCF sandbox project aimed at securing containerized workloads. The idea is that now we have confidential compute. We know we have the hardware. We know how to protect the data in use. How do we enable that for the containerized applications? So the purpose is to extend confidential computing for Kubernetes workloads. And yep. Again, on the screen, we have a QR code, and we have a link, ak.ms, CoCo 101. Please go to this link and check out the preparation steps for the hands-on portions of this session. Does anyone have any problems or issues with the setup? OK. Suraj, to come to you. OK, any questions so far? OK. Suraj? Okay. Okay.
All right. Sorry, Archana will take my place for helping now, because then I can start doing the presentation. So yeah, I'm assuming like people know here, right? Like they have seen this diagram. It's a Kubernetes diagram at a component level, very high level. There's obviously control plane, and then there are worker nodes, and each worker node obviously has kubelet, kubeproxy, and obviously the container runtime and stuff like that. So in this context, what we're going to do is we're going to focus more on the node level So I've zoomed into the worker node. So you have the same Kubernetes cluster. We are looking into a specific node, and it has regular hardware. You don't care like what the underlying hardware looks like or what it has. So the typical interaction looks like there's kubelet, which gives the instructions to contain ID. The contain ID then uses runc to start the application, or pods in this case. So there's nothing, nothing fancy here. Obviously, there is a lot goes behind the scene, but I'm making it a bit crisp. But there are image pull and stuff like that. So pod comes up, but this is a general interaction, right? Slowly we'll build on top of this. Okay. So how many of you have heard of Kata containers? Okay, a couple of them. Okay, we'll go into what Kata does here, but assume the way we saw, like there was a pod coming up, like with runc, instead of that pod with using all the Linux kernel technologies, a VM comes up, and that VM is solely dedicated for this particular pod. It's a micro VM. It's not heavy, and also like compared to the previous slide, you see like this hardware has to be able to do virtualization, right? So again, kubelet comes up. There is containerd. There is Kata runtime. So instead of runc now, there is Kata runtime. So Kata runtime implements those OCI APIs so that containerd can talk to it, right? So Kata runtime knows how to talk to the virtual machine manager. Now it could be anything actually. It could be KVM, QEMU, or Cloud Hypervisor, Hyper-V. It supports a wide range of virtual machine managers. The VM comes up, and the first process that comes up inside this VM is, since it's a micro VM, it's debatable, we can have systemd as well, but right now, Kata agent comes up, and then Kata runtime knows how to talk to Kata agent. And then after 1.7 in the containerd version, you could also implement how you want the image to be pulled with the image snapshotters, right? So the confidential containers project went with Nidus as a default snapshotter. So it is invoked, the image is pulled, and once the image is available, the container comes up, and Kata agent becomes the parent process of this particular container application. So this is a typical Kata. So instead of from previous slide or previous thing or runc-based runtime, now remember that we are starting a VM. So why Kata? Why am I talking about Kata, right? So if you remember, while Archana was explaining about the enclaves, she talked about like it could be a process-based enclave or a VM-based enclave. But process-based enclaves have seen its share of resistance from users because they have to change their ways of doing, especially developers. They have to change their ways of packaging applications. So VMs make it easier, right? And since the VM-based enclaves became like they proliferated with AMD's SEV, SNP, Intel's TDX, VMs have become popularized. So now the confidential containers the project wanted to have this technology which runs in VMs and bring it to Kubernetes for workloads. So what is that thing that marries these two things, right? Like a VM on one hand and Kubernetes on the other. So Kata is the obvious choice. And confidential containers projects went ahead and then extended Kata to be able to use the confidential compute technology. Again, similar to before, now you see there are two more things here. On the right, you can see there is something called as relying party or trustee. We'll talk about it in detail. But assume it's something that you as a workload owner, you run it in your trusted environment, not in cloud or not in untrusted environment. It's like we can go into the depths of like what it will look like or where it is deployed, but understand we assume that this is trusted somehow. It could be on-prem as well, where you control the whole stack end to end and nobody has access to it. Yeah, and on the node side, on the left side, you can see the hardware now, like it has to have those chips, those AMD or Intel-based chips, so that they can start those enclaves. The same interaction, kubelet, containerd, kata runtime, virtual machine manager talks to the, creates a VM. But this time, there are a few more things here. Like on top of the kata agent, there is confidential data hub and attestation agent. So attestation, like all these tools or these extra things, they help you with attesting that this environment is what you wanted. So let's see what happens, right? Kata runtime then talks to kata agent. Nidus comes in. You try to pull that image, but you see that the image is encrypted. So how do you even start an encrypted application? So that's where this whole idea is. Like you encrypt assuming you are protecting your IP of your application, you encrypt that container image, and then you have that key available in the right side, the relying party or key broker service. And when this image is trying to be pulled, it has the metadata in its annotations that it knows, or it says like this is where you can find the key. And that's when this whole attestation is invoked. So the attestation agent talks to the hardware. It gets few measurements and get it signed by the hardware. You send it to the remote entity. The remote entity then verifies, is it good or bad? We'll get into the details of what the remote attestation is and why it is needed. But assume the attestation is successful, it has verified everything is cool and legit, and that's when it says, okay, you look like you're in a very safe or confidential environment, and you can get this key. So once the key is available, the images are decrypted, and the pod comes up, and again, kata agent becomes the parent of that. Of those containers. Now, so there are few disadvantages if you think about it, right? Like Kata, it's a VM runtime, like you're starting VMs. But if you're in a public cloud, you're already on VMs. Like your worker nodes are already VMs. That means you have to start like nested VMs or something, right? So assuming going with this nomenclature here, you have a bare metal, which you don't see, of course, on a cloud provider. All you see is the L1 nodes for your workers. You don't see that L0. You don't even know where it is. So that means that cloud provider has to have a hypervisor which supports nested virtual machines, which is not a big deal. I mean, nested is not new, but like supporting confidential nested, it's the next level. So you have to. The problem with, not the problem, but the thing with confidential compute is like every layer in between has to be enabled or has to have code changes so that the applications can then be run in a confidential environment. So this is fine. Like AMD SAV SNP supports nested confidential compute, but not everyone would do that. Like for example, confidential GPUs. Like what about those? So that's a problem, right? And I think the confidential containers community knew that this is a well-known problem. So they came up with like another implementation of Kata or Kata CC. It's called Kata Remote. So what happens here is you have the same set of cluster. There is a node. It doesn't matter what that node is. It could be like a regular VM. It doesn't have to be even. It doesn't have to support any kind of VM technologies even, right? So it's the same thing. Kubelet comes up, containerd, kata runtime. But this time around, it talks to something called as Cloud API Adapter. It's a daemon set that runs as a part of this deployment. And the Cloud API Adapter is responsible for starting another full-fledged VM. Like assume, if you remember the nomenclature from before, L0 being bare metal, L1 being your regular VMs. So it starts a full-fledged VM, and this VM is dedicated for running that pod, like one VM per pod. There is one-to-one mapping here. Once the VM is up, the similar set of components come into the picture. Kata runtime talks to Kata agent, but there is a proxy there because usually the communication happens over a gRPC protocol, but here since it's different VMs, there is a proxy called agent protocol forwarder, which takes care of ensuring the communication happens there. Same, NIDAS comes up, it sees that it's an encrypted image, with the attestation happens, images are downloaded, decrypted, and available for the application to come up. So today in our workshop, we'll use this form because it's really hard to get hold of like bare metal machines that can, with the confidential hardware. And so Kata Remote becomes the obvious choice for most people because with this technology now, all the cloud provider has to do is they have to enable the regular VMs with the confidential technology. Now, all they have to do is, be it with Intel TDX, be it with confidential GPUs, doesn't matter, right? So anything that comes into the picture, the Cloud API adapter is ready to start that VM's queue. So yeah, we'll use this today. Again, back to workshop setup. I hope you have gotten access to the Azure environment. Anybody facing problems so far? Sure, yeah.
Okay, everyone, we just go and create the AZ account. We will follow through rest of the steps. Suraj will guide you through that and maybe focus on what we are trying to do. And that'll help you understand it better. So no need to rush through the steps. We have enough time.
All right, thank you. Yeah, just raise hand or call Archana. And also feel free to interrupt me. It's not like you have to just wait there. I mean, we want everybody to take home today something and try out all the instructions. So yeah, if anything, just stop us here. So let's look at remote attestation in a bit of detail here. Forgetting everything about Kubernetes, just assuming this is a typical node with which has like virtual machine manager of course, like this is a bare metal machine, and you start a VM. The first thing usually you should do is, like especially with the confidential compute, the first thing you should ensure is that you are really running in a confidential environment. Because I mean, what if the underlying whoever is providing your it could be whoever is providing you hardware, it could be cloud provider or some bare metal setup that you have in house. Like, how do you know it's not being spoofed? How do you know they have just started a regular VM and just promised that it's it's confidential, right? Like, how do you know from within? So that's where this whole idea of a remote attestation comes in. It has to be in your boot path. It has to be the first step in your boot path obviously after the kernel comes up, because without that, you don't. So, and generally what you do in the attestation process is you measure the kernel, you measure the kernel command line, you could even measure the OS disk, and you get all those measurements and then send it to and get it signed by the underlying CPU. So each CPU that is shipped by Intel or AMD, all of those get a key burnt into this chip, and the associated public key is publicly available. So what you could do is you could then send this attestation report to your remote party, which, assuming you are really trusting it, and it then can look at this package, ensure that it was really signed by AMD or Intel, and it's not being spoofed. Because if the remote party can then, that's the whole verification process. If you verify that, and also that's the first step, of course. The second step is also you're ensuring that you didn't get any random kernel, you didn't get none of the OS disk was swapped. Even the kernel command lines are the same as you wanted. So this ensures that the environment is the same that you expected it to be, and you're not being spoofed anywhere. So I always try to bring this analogy of confidentiality being like putting a lock from within. Confidentiality is all about protecting the application owner, because isolation, whenever somebody talks about security, everyone is talking about isolation. They're trying to put whatever the application is within that boundary and not come out. It's beneficial. It's beneficial for the other application if you're running in multi-tenant environment. It's beneficial for the platform owner, of course. But a platform owner can always go into and see what the application is really doing. So confidentiality is that lock from within that nobody can see from outside, right? Or enter without your permission or without you knowing. So you send that, and then assuming the whole attestation is fine, everything is cool. What you do after that attestation is really up to you. Like how you configure this remote attestation part, this relying party. Like do you just want to do like a Boolean thing, like yeah, attestation is successful or unsuccessful, or do you want to release something after that? Like you could be releasing a key for probably like you saw, like decrypting the application, or it could be a key to accessing the data. Like it completely depends on you. So that's remote attestation in a nutshell. So we'll now like I think that was the whole presentation, bringing you up to speed of what this whole technology is, how it's enabled, and yeah, let's jump on the demos. So what I'll do now is I'll be switching between the doing steps and doing demos, and I'll also explain what's really happening in a demo by the diagrams that we saw so far. And yeah, we can see do it together. Mm-hmm. So let's get started, I guess. Yeah. So this is somebody created a PR, you said? Okay. Let's merge it, yeah. And we'll do a live. That's cool. Yeah, so this also changes the Docker image and okay. No. I'm a bit scared about changing the name of the image. But yeah, if you could also send the image so that it tags a new architecture-specific thing without changing the image name, I guess that's the, I guess, review. No, but yeah, let's. Okay, that was that. Okay, yeah, this I can merge right away. Okay, let's. So while we also look at the PRs, well, what I'm gonna do is I'm gonna do the preparation steps myself, which obviously I haven't, right? Sorry, say it again.
Why the image is changing, like for apartment? With the PR, right? The image is changing. The image name was different. Why is that?
Yeah, that's what I'm asking. Like, I don't know. The image changes breaks a few things. That's what I'm a bit concerned. Yeah. Yeah. No, they have not pushed the image. They're changing the image name, so I'm. What? Nilek, I'll use your email ID, by the way, now. Can you tell me your email ID? No, like the work one. I need a work one. I need a work ID. I mean, I cannot start without it because I have retaken it. Okay, I know your email ID. It's not like Nilek at Microsoft. Okay. Okay, so that's up. Meanwhile, I'll also. Yeah, that should be good enough, I guess. Yeah, everyone can see that, right? Oops, sorry. Okay, that's coming up. That's also coming up. Yeah, so whoever has access to, who has gotten access to the whole portal, go forward with the whole AZ login, doing the source, and then running the whole infrastructure, like deploying the AKS, deploying the key broker service or the trustee, the thing on the right that we saw, and the cloud API adapter. Like, yeah, do until here before we start the demo, right? If anybody is facing issues, I can also come in. I mean, it's, okay, I can show how to do that. Can I? Yeah, so if you're facing issues with the gen policy thing, what you could do is, what was the? I don't even remember how to install gen policy. Yeah. Yeah. Okay. There is a script in util. Okay. So when you run that, people who are facing problem with installing gen policy, what it does is it downloads it in some temporary path. So one way to, after it's downloaded, one way to install it would be copy it in path. So you could also check out what your path is by doing an echo on $path. I'm just waiting for this to happen. That way you can, so yeah, it says, right, like it's downloaded here. So if you don't want to do that, well, what you can do is just copy it. Like you can show you my path, and there are a bunch of different locations that you can put into. So if you don't want to install it like globally, what I generally do is I put it in my home .local/bin. But put it in whatever is in your path. So, yeah. And if you're still facing problems, yeah, please. So, like folks facing problem with the Podman support, can I ask you to use that branch specifically? Is it fine? Like who is facing problem with Podman? Lala, okay. I'm sorry, Lala. I did factor in Podman. I should have, yeah. A bit sorry. I'm sorry about this, but like if you could use this branch and also build, like you could also do make Docker build, and then it should if I go here, let me zoom in. Yeah, this should be good enough. So if you look at the make file, you can go forward and do make Docker build, and then that image should be available locally for you to start using it, or Podman build. Sorry. Anybody facing issues so far? I think my environment is still coming up. Wait, it's up. Never mind. I'll quickly copy that. You don't have to go into so here, you can choose to use that Windows machine, but if you want to use the local machine, you can simply paste the copy thing, and it should just copy. So that's not working for you? Yeah, interesting. But so yeah, I was saying like this. If you ignore the VM for a second, I think you can continue to use your local machine. Okay, I'll have to. Okay, so I have access to the Azure portal now, and that's our cloud environment. That's where our whole setup will run. And I'll also, so now I have done all preparation. So far, so good, right? Like people are here so far with me. Like you have local thing running, like using make Docker run or by installing local tools as well. And you have access to the portal as well, right? Any issues so far? Nope. Oh, Archana, can you?
Do you need to use both local and Azure, or is it one or the other?
So this portal, the Azure portal or this website that you're seeing is just for, just so that you see like what's really going on. You don't have to really use it. It's more from visualization point of view. We'll only come to this after everything is up and running. You don't really have to. I mean, yeah, you can choose not to come here, but this is okay. So our next step now I'm done with everything in the whole preparation page. I'm going to the infrastructure deployment now. So I log in locally in that container that I've started. Let's copy this thing. Or even device login should work. Since I'm already logged in, I don't have to then again do the whole password thing in the browser. So yeah, I press enter and I'm logged in locally as well now. So far, so good. Awesome. Okay, so I'll do this source env. So if you look at the env file, wait, hold on. I'll first do a make clean, and now I do a source env. So you can check out the env file, by the way. The env file has everything that we need. like what the like it'll also generate a SSH key. You don't have to look at it, but also what the resource group would be called, what the Azure container registry that we're gonna deploy, because we're gonna encrypt the container image and then push to this registry. So we'll need that. We are going to deploy the worker node is going to be a regular machine. You can see this SKU, this VM SKU is a standard machine, nothing fancy there. Oh, sorry, my bad. The worker node is gonna be standard F4S. That's the standard machine. It is nothing fancy there. The standard DC2AS is what is enabled with AMD SEV's confidential compute setup. And this is all Cloud API adapter. I've just pinned a few things here so that we don't download latest by mistake. Well, I'm downloading latest here because it's just for this repo, like here. We'll come across this as we go forward, right? Okay, so I have sourced that. What I'll do now is let's deploy AKS and everything else. This will take some time, but any issues so far? Who else? Who all have gone through and done the whole deployment or infra deployment? Quite a bit of. Okay. Nice. Okay. And yeah, feel free to call us. Like it's not an issue. Just raise hand. I'll be there as well. Okay, I'm coming there. Okay. Any issues so far? All good? Okay, all right. Okay, this takes time. So basically what we are getting at is we're trying to ensure like all of this that you see here is around, like it's available to use. So that's why the whole first step of doing preparation and everything, right? But meanwhile, if you have any other questions or whatever for around confidential containers or the compute or anything like that. Okay, so it seems like the cluster is created. We're doing creating the identity so that like the daemon set that runs the Cloud API adapter, it can talk to the Azure services because we don't want to copy passwords and stuff around. Yeah. All right. Okay. So first step is done for me. The next steps are not that they won't take like a lot of time. So we're deploying a KBS, the key broker service or the trusted entity, right? This is where we'll be uploading our keys. So that's deployed. We'll also deploy the Cloud API adapter or Kata remote. Okay, awesome. So essentially what we're going to do is, I think like some people have got the setup running, right? So we can then jump into what the demo is going to look like. So the first demo is like we'll create a key. That's the first step here. You see the generate key 1.1. It's a simple random stuff. Like we're just creating a simple plain text key, nothing fancy there. Then we do the whole upload, like here, like you see here. Once that, okay, I see. Okay, what do you mean? Yeah, I think like yeah. As soon as Okay, anyways, let's go through the whole presentation first, and then again I'll go back. Yeah. So once we upload the key, we'll deploy a pod, like a sample pod. It's not there is no encrypted image here, nothing. Once the pod comes up, then we'll do the exec, and that exec command that you see as a part of demo 1, it's doing some curl thing, right? So what that curl is doing is it's invoking a workload specific attestation, like a workload invoked attestation. So this is in scenarios where you don't care so much about the application. The application is generic probably. The data is what you care about, and the application itself then invokes the attestation, gets the key, and then that you can use that key to then download data, which is probably more important than the application itself. So that's what that's what it's showing here. Like you get the key from, you do the attestation, you get the key, and then you see that key on your setup. I'll stop this. And yeah, so that's what we are doing here, right? Like generating the key. Let's see if I have, Okay, well, awesome. So it's the setup is done now. So let's follow this. So the first step is just exporting a key file. Like we'll use this env, or that's why creating a random key and then just looking at what's the output, what's the content of the key. It's just simple random stuff, so that we ensure that this is the key that we got after. So here, assume you are a workload owner. You have created this key now. Then the first step is then we are uploading it, right? It also shows you like where it's being uploaded within the key broker service. And yeah, so now as an application owner, this is what you would do typically. You are preparing your environment. Now let's try and see like what this application is, right? It's a simple application, nothing fancy here. Is the same image that we build with all the tools and everything, and it's just gonna slip. But what in a real environment, what you do is your application, you'd configure the application to download the key from that KBS ID or KBS URL. You see this is the KBS or key ID, also known as key ID. This is so in a KBS setup, you have two things. You have this key ID. So when the application itself is invoking attestation, you can provide it like this. Or when you are encrypting the application, you also provide it in the similar way. But it's just that when the image is downloaded, it knows from the metadata like this is the key. Okay, so we looked at the application. Let's deploy it now. Okay, deployment is created. Let's wait for it. So you'll see like this is not like a typical pod. So if it was a Kata pod or Kata CC pod, it would come up like immediately. So this takes time, in a ballpark of 90 seconds, I think. It takes time because now you're talking to a cloud API, a whole VM is coming up, and that VM will then host your particular application. So that's one of the disadvantages of Kata Remote. Like the uptime or the startup time could be significant. Like. So while that comes up, we can also check out like what's going on here, right, on the portal. If you are new to Azure, what I generally recommend is go to the resource groups section, and you can see this is the resource group that we created. It has the AKS, I think it's visible, right? Yeah. So it has the AKS deployed or Kubernetes service deployed, and the respective pod VM has come up here. Like it's a full-fledged VM. So that's the thing with Kata Remote. Like from a Kubernetes point of view, it's just another pod, But from the cloud provider point of view, or from the cloud portal, you can see it's a full-fledged VM. Okay, let's see what's the status of that. Okay, it says it's running. Anything? Okay, it doesn't look like anything is wrong there. Okay, it's running. It's running. Awesome. So now that it's up and running, we're going to do a application invoked attestation, right? So what's happening here is I'm gonna find the pod name, then exec into that pod here, and then do a curl. So this curl, what it is doing is it's talking to that local CDH or confidential data hub, which exposes itself within the container on localhost 8006, and then you can do a resource/key ID. And you remember the key ID that we have exported before. This is where we uploaded the key to. Like if you look at the logs from, so this is what we did. Uploaded the key here, and then from that's what we're telling the application. So application has to know like where to get the key from, right? Okay, let's run this thing. And so that's what we got from KBS. Like after, so attestation has happened, like everything has been done successfully. Now let's look at the key file. So basically I'm trying to show you like this matches, right? This is as a application, while preparing the setup for application, you have uploaded the key, and through the application you got the same key. And you can also see, you can look at the KBS logs here. It shows you what was really going on there. Like you can see here, this is the key that we requested the KBS to give us, or specifically here. All right. So far, so good. Any issues or questions? What's going on? Like, why are we doing this? Okay, all right. So let's look at the encrypted image now, right? Like that's a bit. I'll clean up this thing so that like we don't have that lying around. Let me switch to the demo again. That was, I think that is the wrong slide. Yeah, so demo 2. So in demo 2, what we're gonna do is we're gonna create a key, encrypt a container image, upload that key similar to the previous step to the key broker service, then deploy that pod with the encrypted image, and once the local Kata agent service knows that or recognizes it's an encrypted image, it will invoke the whole attestation process that we saw like before. Like before it was all application invoked. This is like automatically happening for you. So the attestation happens, you get the key, it's decrypted. It's the same thing like before, right? And then we'll see this application from the browser. So let's do that. Okay, let's look at what this source image thing is, right? So source image is like, you can run this thing locally and you'll see like it's just exposing a Nginx based like a thing, like a Nginx application, and it's just serving like a simple image, nothing fancy there. So, and we'll encrypt this image, this particular image, right? And then you can even try to download the encrypted image that I created, and you'll see that you won't be able to run it because it's encrypted. Or you can even try to download your own encrypted image, and you'll see in a local environment, and you'll see that it won't run because it's encrypted. So okay, let me talk about what's going on here. We downloaded this application. This application is also shipped as a container image, like the application that encrypts your container image. Once that is done, it creates a key. You could typically also give it like a 32-bit key, and now here it's seeing what application. Okay, so it started that key provider, or the thing that will encrypt your application. It will encrypt it's encrypting the application here, and this is the new name of the application, or this is the registry that we created, the container registry. So the image is encrypted and uploaded. And so here what I'm trying to show you is, like, even if you create like a new environment and try to download the same image, you won't be able to use it because it's encrypted. It's just to show you. So just creating a DIND environment, like a Docker and Docker type of thing, and okay, so Docker and Docker is created, and within Docker and in that Docker and Docker environment, we are now pulling the encrypted image. So it would be you'd successfully pull the image, but not like really see what's going on. You see, you see these errors. So let's look at like what the typical annotations or like this metadata looks like for an encrypted image. So we'll use this tool called CoCo. So what CoCo does is you can give it any image, be it locally, be it remote, on a container registry, and you can look at like all the JSON metadata that you get. So here specifically what I'm looking at is I'm picking a random layer, like a first layer, and then looking at this annotation called org.opencontainers.image.encrypted.keys.provider.attestation agent. And since it's a base64 encoded content, we'll decode it, and then again we'll feed it to JQ so that it looks pretty. So here you see like the key ID that like we saw before when we were doing application-specific attestation, remote attestation. This is encoded in the image itself. So when that image will be downloaded, Kata agent knows, okay, this is what I should query. This is how I'll get the key to decrypt this particular layer. We can even look at this, what this thing is, right? It's all garbage, right? Or unreadable. So anyways, so now we have that, we have created a key, use that key to encrypt an image. So those two things are ready. Let's upload that key to the key broker service, or the remote entity which we trust. Okay, so the key is uploaded, and it's cool. Now let's look at the application that we're going to deploy. So what's happening here is it's a simple encrypted image, and I have parameterized this image because everyone will have a different image name depending on their container registry deployment, and we'll expose it as load balancer so that we can then access it over the web. All right, let's deploy this thing. And wait until it comes up. Any issues so far with the demo 2 encrypted image thing? Also, if for whatever reason you couldn't follow the demo, like, you can always try this at home as well. Like, it's pretty. And feel free to reach out to the, so we have a confidential containers handle or channel on CNCF Slack. So you can reach out to us there even for demo issues. Okay, so it's up and running. Now what we're gonna do is like get the public IP of this application, since it's running as a load balancer service. And then we can we can see that it's running, yeah. So basically, it's trying. What I'm trying to show you is like we created an encrypted image, uploaded it, but we couldn't run it locally because it's encrypted. But it can run in an environment which can download the key and then decrypt it. Also, let's look at the KBS or the key broker service logs, and it tells us like what was going on here. Like there was the key fetching happening for each layer because there are multiple layers for this container image. Any questions or issues? But before I delete it. Any questions? Anything so far? All good? Awesome. Either everyone is following or they're completely lost. Awesome. Okay, I'll clean up the environment, and then I'll quickly show you what's the demo 3. So yeah, demo 3 is all about, so like we saw in the first demo, right? Like we were execing into that particular application, but I mean, if you think about it, don't you think it's compromising confidentiality in a way? I mean, if you can exec into it, like whoever owns the Kubernetes cluster can exec into it. Like you're getting the whole control plane into your confidentiality boundary, which is not something you want. You actually want everything outside that particular pod. It's hostile. It's malicious. Who knows who can do what? So. Like, and going back to that analogy of putting a lock from within, you would want some mechanism to disallow the control plane to do anything with your application. So that's where policy comes in. So what we're going to do is we're going to again deploy an application with a regular policy, which is wide open. It allows everything, and you'll see we can do exec. And then we'll deploy it again with a different policy, and you can see that we disallow exec. So that includes disallowing logs also. Like you can disallow logs also if that's something you think is confidential and should not be exposed to the control plane. So let's see how that will look like. So let's look at the application. So what you see here is these are all the operations that your Kata agent allows, right? So all of this is set to true right now, and depending on how you want to lock down the application, you can change the parameters and redeploy the application with it. So that's the policy. I mean that was allow all policy actually. So. This is the application, nothing fancy again. It's a simple Nginx based on Alpine, and yeah, let's use this gen policy tool. So this is a tool created by the Confidential Containers project itself, and it aids you in creating a policy. And the way also let's run it and so that I can show you. So the way this policy works is it will create an annotation on the pod configuration itself, so that when you deploy. It gets passed on to the Kata agent, and it knows what's something that's not allowed or what something should be blocked. So if you look at the modified application config, you can see there is this new annotation created. It's a bit huge, but the application is the same. It's just this new annotation is added. So let's deploy that. Well, the first step is a bit underwhelming because you can see you can exec, and well, that was supposed. I mean, that was happening all along, right? The second part will show you the power of policy. We'll wait for the thing to come up. Okay, it's up and running. Also, by the way, just to check, like if a pod is coming up with like if it's really using that new runtime that we deployed, what you could do is you could just dump the whole pod configure. So let me just and grep for runtime class. And it shows you like this is running with a different runtime. Like it's not runc based. If it was runc based, you wouldn't even get any grep output here. Anyways, that was slight detour. So let's try to exec that application into that application. And like I said, we can, like this is a curl, and it's the curl output. It's a bit underwhelming. Like I said, you could. You were doing that all along. Let's delete that and redeploy with a new policy. So in this policy, all you'll see is like this is the only thing that's different. We are like, just for the demo purposes, we have disabled only one thing, which is exec. So let's use that policy and regenerate the pod config from before. This step was just to show you the diff between the two policies. Like here, the exec process request was allowed, and in this one we are disallowing it. Now let's deploy it, or not deploying. We are creating a policy, or we are using the policy to update the config. And here again, it's all base64. You can copy the whole thing and you can see what's going on. It's basically the same output that you saw from here. Like this is the policy that is generated, and it's a base64. It's encoded into base64 and added as an annotation. So you are ensuring you're not doing anything more than what was allowed from the policy. Let's deploy it. And I'll wait for the thing to come up. Okay, the question is which step are we on? We are doing the 3.2, the disallow exec policy, which, okay. And then we have deployed the pod now with the disallow exec policy, and we're waiting for it to come up. Any questions or anybody blocked on anything? Nope, I guess not. Okay, it's up and running. Now, if we try to do the whole localhost, curl localhost, you see that it gets blocked. Basically, kata runtime itself, the kata agent itself blocked the exec, and then that error is propagated all the way up to containerd, kubelet, API server, and to us, right? So yeah, that's basically one way to keep the control plane out of your confidentiality boundary. I guess that was our workshop. Yeah, I'll start from here. If you have, I think we have 10 minutes. We can take questions, or we can help people debug the setup if you have any problems. These are all the references that for the images and stuff that we used. There's also the last link gives you, the slides are already uploaded to the today's the page, the SCAD page, so you can even download it from there. You don't have to. Yeah, and you can access those links. And there are more confidential containers sessions going on. I think ours was the first one. This page links For the other sessions, like there is one from NVIDIA around the confidential GPUs and the confidential compute, how they. So yeah, you can find it here. And if you have any questions, whatever feedback, we are here.
Do you want to summarize, like, a little bit about what demo 1 accomplished and what demo 2 accomplished and what demo 3 accomplished? I mean, might be straightforward in your eyes, but because like people like me who was new to confidential the containers, right? Maybe you just summarize.
Yeah,
Like,
I can summarize quickly. Yeah. So the question was, like, can you get a summary of like what all the 3 demos achieved? So what we did with first demo was to showcase like what the application invoked remote attestation looks like. So like I said, for an application where you don't care about what the importance of the application, it could be a generic inferencing service, for example. You don't care about it because it's open source, but you care about the data itself. So where do you get that data from? It's living somewhere in an encrypted S3 bucket or whatever. So that key could then be used to download, decrypt that data or model and start serving. So the first demo was to showcase how application can invoke it. The second demo was about where you care about the application also. Nowadays, there has been a lot of talk around how models are important and OCI images can be used to ship your models. So at that point, you could use the encrypted image technology to have your IP protected as well. And I think the third one shows you, just encrypting images or just doing application-specific attestation is not enough. You also have to put your Kubernetes control plane out of your confidentiality boundary. So policy gives you that capability to disallow API server from doing anything. Yeah. Archana wants to add something.
Okay. So from the perspective of confidential compute, what demo 1 kind of showed was, you have this environment given to you, and it just said that, this is a confidential CPU or it's a confidential GPU. Are you supposed to trust that? Like, why would you trust that? So demo 1 is basically about attesting that environment, proving that it is a trusted execution environment, and once that is proved, releasing something sensitive into that environment, such as a key. Now, in demo 2, you're basically using that released key to decrypt something which is important to your environment, for example, your image or your workload. And in demo 3, we saw that you have this confidential compute environment. How do you protect it from outside world? So you have the peer pod, which is a VM, and which has a cloud API adapter. Your control plane is talking to that cloud API adapter to deploy your workload, do things inside it, such as exec into it. Now you are paranoid, you just want to disable that as well. You don't want anybody to get into your pod once it is deployed. So you can use policy to do that. You can use policy to disable a lot of things, such as setting policy again itself. So those are the 3 demos from the perspective of confidential compute, what it entails. Any other questions?
All right, cool. If there are any other questions or whatever, you could reach out. Oh, there's one, sorry.
I think you actually went a bit into that, and I just didn't understand. But on a very fundamental level, why is there the need to, or is there a technical need to do this in Kata containers, or is Kata containers just a convenient way to do it because you get VMs with you automatically schedule that and can schedule that in VMs that have those hardware modules enabled, or would there be a technical possibility to start confidential computer and containers on pre-existing nodes that have that hardware enabled?
So I think you're asking from a point of view of like, can we just have environment already prepared and then you deploy into it? Like, is that the question? So yeah. So there are multiple ways to use confidential compute. What Kata or what confidential containers is doing is the trust boundary is limited to your workload or your pods. Like everything, it's assumed everything else outside that is malicious. You cannot trust that. So that's one way to do it, where you're only caring about that workload. But the other way would be you have all the hardware, you deploy everything yourself. Since you're doing it, you're deploying everything, the whole environment is trusted in a way. Since here we were talking about shared environment on cloud providers, we don't know where it's a managed cluster again. We don't control the application owner doesn't control what happens from the API server. We don't control the underlying layers of hypervisor. But if you have your on-prem setup and you still want to use confidential compute, you could do that, yes. But again, like it's a matter of how much you wanna. There too, what kind of control you have. Do you have some admins controlling it, or is it your own team and you know who you can trust and who you cannot? But there are some offerings from Edgeless. There is a company called Edgeless, and they also have a booth, I think, here, which go into these kind of setups. Yeah. I hope I answered your question. Great. Okay. All right. Any more questions? Okay. All right. Cool. The environment that you have, it will last for another few hours. It'll still be there, and you can continue to play with it. And if you have any more questions, anything, feel free to reach out to us on the confidential container Slack. On the CNCF Slack, there is a #confidential-containers channel. And yeah, thanks for coming in and following along. I hope this was helpful. All right.